Hello everyone. Today we will discuss 7 segment display. We know that this is 7 segment display which is used to display your digital value from 0 to 9 and letters A to F. Okay, this is commonly used for displaying the information. We are using this for various applications such as a digital clock, electronics meter, instrumentation panel, digital readout display, etc. Now this 7 segment display having 8 segments, that is A to A B C D E F G, and one is H, that is nothing but your decimal point. Suppose you for example, suppose you are using this 7 segment in a calculator and you want to display number 5.1, that time you are taking help of this decimal segment. Now in a 7 segment, these 8 LEDs are connected in two ways, either in common cathode or common anode. In common cathode, all cathodes are connected together and it is connected to ground. Okay, now to turn on this LED, your controller will send one here. When this is one and other end is ground, that time current flow through the LED and LED turns on. Okay, means here one is on, and when you are providing here 0, controller providing 0, in that case this A terminal is 0 and other end is also 0, both are equipotential, and that's why current will not flow and LED remain off. Means in common cathode configuration, 1 is to turn on the LED and 0 is to turn off the LED. In this fashion, controller will send the signal to turn on respective LED. So in common anode configuration, here all anodes are connected together and it is connected to VCC. Okay, and other terminal is connected coming from the controller. When controller send here 0, that time current will flow through the LED and LED turns on. Okay, means here when you are providing 0, LED turns on. Whereas when controller send here 1, in that case this is 1 and other end is also 1, and that's why both are equipotential, and that's why current will not flow, and in this fashion LED remain off. In this fashion, 1 is on, 1 is off, and 0 means on. This is the condition for common anode, which is exactly opposite of common cathode. Just see here the number. This is common anode configuration. As you are changing the parameters, according to that you are displaying number 0 to 9, and it is continuously displaying 0 1 2 3 according to whatever input you are providing through the controller. Now in this fashion you can generate any number on 7 segment A to F, 0 to F. Okay, according to that respective LED turns on and other are off. Now in our practical we are using common cathode. In common cathode, when controller send 1, in that case LED turns on. Means suppose you want to turn on the LED, a LED on, in that case you are providing here 1, and that time this respective LED turns on. Okay, now according to that, first calculate the lookup table. Now suppose you want to display 0 on 7 segment display, in that case all LED must be on except G and H, and that's why I am placing here 1 to all the segment except G and H. Okay, when you are writing this type of number, you are getting the actual hexadecimal number, that is, this is nothing but higher nibble is 3 and lower nibble is F, and this in this fashion hex code for displaying 0 is 3F. Similar way you can generate hexadecimal code for to display 1. When you want to display 1 on 7 segment display, in that situation B and C segment is on and all other segments are off, and that's why you are providing B and C as 1 1 and all other as a 0 0. After that, just calculate the number. According to this situation, lower nibble becomes 6 and upper nibble becomes 0, and in this fashion 06 is the code for to display 1 on 7 segment display. In this fashion, create the hexadecimal code as per the each number which you want to display on 7 segment, and create the lookup table, and in this keep this lookup table into the memory, and one by one you are calling the hex code from that lookup table and pass to display on 7 segment. That is the task. Okay, here we just mentioned that in common cathode and common anode it is exactly contrast, because in common cathode 1 means on and 0 means off, whereas in anode 1 means off and 0 means on, means exactly opposite of common cathode. And according to that, hex code is exactly opposite, that is listed here. Okay, now according to this much knowledge, we want to achieve the problem statement. Now my first problem statement is I want to interface single 7 segment display to 8051, and I want to display decimal or hex counter. Decimal counter means I want to display number from 0 to 9, and hex counter means I want to display number 0 to 9 and then A to F. In this fashion, I can create hex counter or BCD counter with the help of 7 segment display. That is my first problem statement. And next problem statement is multiple 7 segment we want to generate. For example, 4 7 segment display to generate 4 digit number from 40 to 4F. Okay, these are the two problem statement we want to cover. Now, according to first problem statement, first one 7 segment display is connected to 8051 here, and for that you are using one port. Okay, now as per my problem statement, I am just using single 7 segment display, and on which I am displaying hexadecimal or hex counter. And for that I am writing the code in both the languages, either in C language, embedded C language, or assembly language. First I will explain with the help of embedded C language, and then embedded and then assembly language. First, suppose I am using embedded C. In that case I am just writing the code. I am just including the file header file of 8051. Then I am just declaring the port where I am connecting the 7 segment display. Now it is connected to P2 port. Then I am just calling the delay subroutine. Okay, and that's why I'm just declaring variable n, and continuously it get updated till it is not become 0 to introduce that much delay. Next one is we are writing the main function. In the main function I am declaring one variable I. Its type is unsigned integer. I is the variable whose type is unsigned integer. Then I am just creating the array whose name is a segment, and within that array I am just keeping the hex code of each number from 0 to F. Okay, and one by one I will call from the main function. Then in while one, because we want to display the number hex counter or BCD counter continuously, and that's why I'm just writing while one loop. And in that case I'm just varying the variable 0 to 16, means I want to display number 0 to F, and that's why every time I get incremented from 0 to F. Then in a segment, just take the data from the array whose name is SEG, and one by one variable is taken and it is passed to the segment. Segment 2 is nothing but your port 2, where we are connected 7 segment display hardware. Then we are just calling the delay to see that variation. In this fashion, we are continuously taking one by one data from lookup table and pass to 7 segment display. And every time we are just calling the delay because we want to see that number. In this fashion, we written the code in C embedded C. And suppose we are writing the program in embedded C, that time just save the file with .c extension. Whereas suppose you are writing the code in assembly language, you just save the file with .asm extension. Now we will discuss same problem statement with assembly language. Now algorithm for that, just decide which logic you want to use. Either you want to use common anode or common cathode. Now in my case I am using common cathode. Okay, and next I am just generating the lookup table as per the which counter I want to generate, either hex counter or BCD counter. According to that I just create the lookup table. Okay, and then assigning one by one value from that lookup table and pass to port 2 with some delay to see that number on 7 segment display. Now these are the basic step of the algorithm to achieve that final goal or final problem statement. Now I'm just converting that algorithm steps into the code. Just now see the code. Now first step is the start. Initially you are started from org is 40h, but this is the location for register bank, and that's why I'm just the start label, which is available at 0030. This is the starting point of scratchpad. This we are writing the code in a scratchpad. Then in start label, first we are taking the count. Suppose I want to display 10 numbers. That time this 10 number is taken into one of the general purpose register. Okay, now I am using one general purpose register, that is R1, and within that I am just placing the number 10. Means 10 is the count and it is placed into the R1. Means now R1 is working as a counter which is counting all 10 numbers from 0 to 9. Then move dptr comma hash 400h. Now you are keeping the lookup table into the external memory, and whose address is 400h, and that is pointed by dptr. Dptr is the only pointer point the external memory, and that's why that address of lookup table, that is 400h, we are placing into the dptr. Then next thing, then clear accumulator first. Then take the data from A plus dptr. A is nothing but 0 plus dptr, and dptr showing the location 400h. Take the data from that location into the accumulator. Now this data is coming from the extra code memory, and that's why we are writing here move c. Move c is means it is coming from the code memory. Okay, means whatever data hold into the code memory, which is shown by dpt A plus dptr, is coming into the accumulator. Whatever data coming in accumulator is passed to P2 port, because 7 segment display is connected to P2 port. Then just call the delay to see that number on the 7 segment. Then increment the dptr. Now dptr showing 4001, means it is showing the next hex code. And then decrement R1. Out of 10, one digit is already displayed. Now it is decremented by 1. Now it's become 9. Then check it is non-zero value. Then move back again. Okay, means again you will come here. Then clear the accumulator. Then again A plus clear 0 plus dptr. Now it is showing 401. Take the data from 401 and place into accumulator, pass to the 7 segment display, call the delay, then increment the dptr. Now it is showing 4002. Then decrement R1. Now out of 10 digit, two digits are out. Now just check it is 0. No, again it is 8. That's why again move back. In this fashion, one by one data you are taking from the lookup table, and it is passed to the display. Means this loop executed how many times? 10 times, because our counter is R1. R1 is equal to 10, and that's why this loop will execute 10 times. And then as jump start, again move back. Means you are displaying one by one all numbers from 0 to 9, 0, 1, 2, 3 up to 9, and again you are moving in the same loop again, that is again 0 to 9, 0 to 9, 0 to 9, like that, and it is remain in infinite loop. And in at 4000h we are creating the lookup table, and just declare the type of uh, data, that is it is byte type data, and that's why you are declaring as a defined byte. Suppose your data is word type, then write here dw. Suppose your data is double word, just write here dd. But our data is 8-bit data, and that's why we are writing here db. Db is nothing but defined byte, or means data is its type is byte type. In this fashion, whatever hex code you have calculated from lookup table, just place here sequentially, and that number will display continuously on the 7 segment display. Now you just call the delay, write delay subroutine. Delay subroutine you can write by the two way, either for loop or timer loop. Here we are using the for loop. I'm just placing the count, and I'm just keeping in loop till it is not become 0 to introduce that much delay. Okay, now this is your first problem statement. Now according to that I will show the demonstration of that. Now this is the actual code. Just take the code and place in a kill software. Now in kill software, just I will repeat the step procedure again. Just open the project, then new project, then in MA, in final, in 7 segment, just give one name here. For example, I am just giving name here as SE1 2. Sorry, here SE12. Any name you can give here. I'm just giving here SE12. Okay, then save that. It is saved on which folder? In 7 segment folder. 7 segment folder is where? In final, and final is where? In MA. Okay, just save that. Okay, once you save that, then demanding for the choose the device. Now we are choosing the device from Atmel family, and my number is device number is 89C51. Then say OK. Then it is saying for starter file. Yes, we want that starter file. Now the starter file is coming into the source group. Okay, then you create a new file here. I will just type the code here. Now I am just paste that code. Okay, once this code is over, then I will just save that code with the same folder in MA final in 7 segment. My file name is se12.asm with .asm because our program is in assembly language. Okay, now color get changed. Now just add this assembly file into the source group, and that's why just right click on source group, add file to source group. Which file? That is se12. Yes, .asm. Add, then that file is coming here. Then just close this. Once you close that, on a target one, just right click on target one, choose option window for target. Now this option window will open. Then just see which device is there. That is AT89C51. Then just place the crystal value here. Now I'm just placing the crystal value, that is 11.0592. Then just go to the output window. Then just see here what is the name of your file, that is SE12. Okay, now where it is, that path is given here. Now it is in a 7 segment. Now where is the 7 segment? It is in a final, and final is in a MA. Okay, now just remember this path. Then say OK. Now you know the path also, and what is the name of the file? SE12. Then you want to create that hex file, and that's why click here. Then say OK. Now once this procedure is over, then build the program. Now just see here, there is no issue, there is no error, and that's why hex file is generated with the name SE12. Okay, now just dump this code on your Proteus software. Proteus software के लिए just go to open the Proteus software, that is IS 7 professional. Then Proteus software get open. Now I already constructed that design. I will just open that. It is in MA, E drive, MA, final, 7 segment. File name is hex segment. Open. Now this design is available. It is connected to P2 port. Okay, now I want to dump the my hex file into this 8051, and that's why just double click on this. Then give the proper path. My file, that is SE12, is in E drive in MA final 7 segment, and my file name is SE12 hex. Okay, I'm just choose that file, say open, then say okay. Now that file is dumped into this. It is 8089C51. Now you just run that code. Now just see here, all numbers are get displayed from 0 to 9. Okay, means this is your decimal BCD counter, and suppose you want to generate hex counter in lookup table, just add the hex code of A to F also. Okay, in this fashion we just display the number 0 to 9 here because it is a BCD counter. Here I value is 0 to 9 only. Okay, now we will discuss next part. Now just stop this figure. Now just go back to the presentation. Now next problem statement is multi 7 segment display. Okay, in that case all displays are connected in parallel to one port only, and only one display is on at a time and for very short duration, and we are doing it so fastly that we are observing that all segments are on at a time, but physically it is not there. At a time only one segment is on. Now this is your interfacing diagram. This is previous one is for 2 segment, this is for 4 segment. Now algorithm, first decide which method, which logic you are using, common anode or common cathode. Then create a lookup table. Okay, which number you want to display. Then multiplexed 7 segment is there. That's why just choose one of the segment by proper control signal, and then take one value from the array and pass to port 2. Okay, now in here I am just generating the two 7 segment display. I am connecting here, and I want to display one particular number on that 7 segment display. Okay, my number is 17. I want to display number 17 on two 7 segment display. On first 7 segment number 7, and second 7 segment display number 1, and in this fashion I will just see 17 number on 7 segment, two 7 segment display. And that's why I'm just starting the program. I'm starting from the scratch pad. Initially clear the port 2 because 7 segment display is there, and that's why you don't want to display anything else, and that's why just clear it. Then you're placing the desired number into one of the general purpose register. Now one number you are placing in R6, second number you are placing into R7. Okay, then clear port 3 because you are using port 3 for choosing one of the 7 segment display. There are two 7 segment display, you are choosing one of that. Okay, and initially you are just making it 0 0, means all 7 segments are in off condition. Then place first number, that is 1, is taken into accumulator. Then your role is to activate first 7 segment display, and that's why you are just making set bit P3.1, means first 7 segment display will turn on because you are just applying here 1, and that's why first 7 segment display on. Then whatever in accumulator pass to P1, particular port. Okay, then call the delay because we want to see that number. Then clear P2.1, means your first 7 segment display will open, will turn on, and we are displaying first number on that 7 segment display. Then next R7 number taken into the accumulator. Now this second number we want to display on second 7 segment display, and that's why I am just activating 3.1. 3.1 is the enabling second 7 segment display. Okay, when second 7 segment display is on, that time whatever in accumulator pass to the port, and then just call the delay to see it on second 7 segment display, and then deactivate it. And s jump main, means you are continuously doing this same thing, means first 7 segment on, then after some time second 7 segment is on, but the speed of controller is very fast, and that's why human beings just see that both the numbers are looking at a time on both the 7 segment, but it is not like that. It physically only one segment is on at a time. but it is doing so fastly that human being just see that it is in a continuous fashion. Okay, then write the delay program. Now this is a figure for 7 segment display. One port is connected, all 8 bits, and these pins are for next for choosing one of the 7 segment display. Okay, now I will just take that code of multi 7 segment display. I am just taking that code and paste into the Kill software. In Kill software, already I know the method. Okay, within this only, instead of this program I will paste new program, because okay, we know the procedure. I'm just following the same procedure, and I am just writing my new code here. Then just save that program, then build the program. Now some error is coming, just double click on that error. Now error is here, just verify what is the error here. Okay, two times main is coming two times, that's why just remove that main. That's why it get confused. Save it, build it. Now there is no error. Okay, now just dump this code in Proteus software. Now the same code, now new code is developed with the same name, that is SE12. Now in Proteus software, just open the new design of multi 7 segment. Now the design is in a E drive, in MA folder, in 7 segment. No, not it in 7 segment, it is in final 7 segment, and multi. Now this is a two segments are there, and they are connected to single port. Okay, within this I am just dump my new code. My new code name is in E drive, in final, in final 7 segment. New code is SE12. Okay, then open that, then okay, and then run that program. Now just see here, we are displaying number 17, and it is coming here on the both the 7 segment display. And this cover your 7 segment display practical. Okay, thank you.